Pascal's triangle. This is a delightful pattern that is going to allow us to expand binomials quickly. Expanding x plus y to the 0 is simple. Anything to the 0 is 1. X plus y to the 1, that's just 1x and 1y. X plus y squared, I believe you're familiar with x squared, 2xy and y squared. Now, x plus y cubed. X plus y cubed would be taking x plus y and multiplying it by x plus y squared. So let's do that. X plus y multiplied by x plus y squared, which we know is x squared 2xy and y squared. So let's multiply this out. Let's multiply all of these by x. We'll get x cubed 2x squared y xy squared. And now we multiply all of these by y. So x squared y 2xy squared and y cubed. Let's collect any like terms. We have x cubed x squared y and 2 more of them, so 3x squared y. Two xy squared and another xy squared, so that's 3xy squared. And then our final term, y cubed. Now that was a fair bit of work. I really don't want to do this again to get x plus y to the 4th, because we'd have to multiply x plus y by all of those terms and collect our like terms. So what we're going to do instead is we're going to look at the pattern made first by the coefficients. So the coefficients 1, 1, 1, 1, 2, 1. If we put them in triangular form, we get this picture. We notice we're always starting with 1 and we're always ending with 1. How did these middle terms come about? Have you noticed that when you add those two together, you get the term below? So what's missing in this row? The 6 comes from the 3 and the 3. The 3 and the 1 give us 4. So the coefficients in the next row should be 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. There's another pattern you want to look for. Let's look at the exponents on x. When we were cubing it, we had x cubed, x squared, x to the power 1, and then no x's, so that's x to the 0. What's going on with y? Y starts at 3 on this side, then 2, then 1, then 0. Are we following the same pattern here? Starting with exponent 4. So the x, exponent 4, 3, 2, 1, no x's, so that x to the 0. And what about y? 4, 3, 2, 1, and no y's, so that's y to the 0. So if we can understand this pattern, we should be able to expand binomials fairly quickly. Let's try it. X plus y to the 7. Our first job is to identify the coefficients. So look at that. I happen to have a few rows of Pascal's triangle. This is the expansion of x plus y to the 0, 1, 2, 3, 4, 5, 6, 7. So we know that these are the coefficients that we're looking at when we expand x plus y to the 7. You might notice a quick way of figuring out which row you want. Do you see a connection between the exponent and the second term in the triangle? So if you create the triangle, you know immediately which row to go to. So our coefficients 1, 7, 21, 35, 35, 21, 7, 1. Here are our coefficients. What I recommend you do with your coefficients is put 2 brackets beside it. Then get your exponents right. Exponent starts at 7. So the first bracket, 7, 6, 5, 4, 3, 2, 1, 0. Your second bracket starts at 7 on this side, 7, 6, 5, 4, 3, 2, 1, 0. If you'd like to check, you notice what these exponents add up to. Your pairs of exponents should always add up to what you're expanding it to. So if they all add up to 7, we know we're on the right track. Now what to do with these brackets? Take your first term and put it in each one of the first brackets. Take your second term and put in each one of the second brackets. After that, we simply clean this up. 1x to the 7 times 1. 7x to the 6 times y. 21x to the 5 times y squared. 35x to the 4 y cubed. 35x cubed y to the 4. 21x squared y to the 5. 7x y to the 6. 1 times 1 y to the 7. Nice and quick. So let's refresh. What did we do? Expanding to the power 7, we went to this row of Pascal's triangle. We picked out the coefficients. We wrote the coefficients down with 2 brackets and put the exponents in. Then we put the first term in the first bracket and the second one, including the sign, in the second bracket. So why don't you see a plus sign? Because it doesn't change anything. If you have a positive raised to the exponent 0 or a positive raised to the exponent 1, it's still positive. So we have to watch out for the sign, the plus or minus, but it did not matter in this case. And then you simply get rid of all your brackets, remembering that all these terms are multiplied together. So 7 times x to the 6 times y gives us 7x to the 6y. Let's try a second example. X plus 2 to the 5th. Which row of Pascal's triangle do you want? Here's an easy way to determine which row. So we'll take the coefficients 1, 5, 10, 10, 5, 1. Those are our coefficients. Put 2 brackets beside them and make sure your exponents are correct. So the starting exponent would be 5, and then 4, 3, 2, 1, 0. The second bracket, 5 on the right, 4, 3, 2, 1, 0. First term goes in every first bracket. Second term goes in every second bracket. And then we clean it up. 1x to the 5 times 1. 5x to the 4 times 2. 10x cubed times 2 squared. 10x squared times 2 cubed. 5x times 2 to the 4th. 1 times 2 to the 5th. Now, you're not going to leave your expression like this. That would give us 10x to the 4. What would this one give us? Make sure you square your 2, multiply by 10, I'm getting 40x cubed. 2 cubed is 8 times 10 is 80x squared. 2 to the 4th is 16 times 5 is 80x. And 2 to the 5th is 32. So it's a little more complex when you have numbers because you actually have to work out a little more math, but it's the same thing. And again, it's nice and quick. Let's try this one. X minus 3 to the 4. Which row of Pascal's triangle? Remember, this is what's going to tell you which row. So our coefficients 1, 4, 6, 4, 1. Now for those of you asking yourself, do I have to memorize this? I don't memorize it, I just remember how to create it. I know it starts with 1, I know it starts and ends with 1. And then to get the middle term, we add those together. So I know I start with 1, I end with 1. To get the middle terms, we add those together. And we're having to go to 4, so we need 1 more. Start with 1, end with 1, add the middle terms together. And for those saying, oh, that's a lot of work, it's a heck of a lot more work to multiply this out. So trust me, this is quicker. Coefficients, 1, 4, 6, 4, 1. Get your exponents right. First bracket starts with 4, 3, 2, 1, 0. Second bracket goes the opposite, 4, 3, 2, 1, 0. First term in first bracket, second term including the negative in the second bracket. Be careful of your negative signs. Let's clean this up. X to the 4, anything to the 0 is 1, so that's x to the 4. 4x cubed times negative 3. 6x squared times 9. 4x times minus 27. And 1 times 81. Clean it up. We don't leave them written like this. And again, remember, these are all multiplied together. So x to the 4 minus 12x cubed, 54x squared minus 108x, and 81. Your job today, A to G. Now, why do you care? When we get into limits, we're going to be expanding expressions like this often. You need to be good at it, because if it takes you too long, you just don't have time to do any of the work. So we have to get quick at this. It won't take you very long to get good at it. You just need a few questions to practice on. Work on writing down your triangle, and that will help you remember it. Remember your exponents, and then clean things up. Should be a good day for you.